All right, so number 4 on the on worksheet number 4, the tangent one, amplitude versus vertical shift is a good question. I think they tried to put a dot right there, and that's sort of where it makes the wiggle. That's not the official word. I mean, the official word is it changes concavity there, but we're not really talking about concavity in pre-cal. But so I think the midline is right there, and so that means it's been moved up 1, because that's exactly where it makes the little wiggle, for lack of a better term. The amplitude for tangent for us is always going to be 1, because it's just too hard to tell otherwise. Because all it would do is stretch it out more, and it would be tricky to tell. As opposed to sine and cosine, where there's a clear top of the mountain when you stretch it out. With tangent, when you stretch it out, it looks a little bit different, not much different. So for us, our amplitude will always be 1, because it's too tricky to tell if it's anything other than that. All right, period. Well, you know what? I'm going to back up and highlight one cycle here, because I think that helps me see, kind of focus in on, rather than looking at the whole thing. By doing that, I think I see where the asymptotes are. So the distance between the asymptotes would be a period. Would be one way to find the period. You could also go 0 to 0. That's kind of how we do it when we're graphing. We start at 0 at the origin or at the new origin, and then go 1 period away. So from the 0, or the starting point, to the next 0 is pi over 2. If we look from asymptote to asymptote, it goes from negative pi over 4 to pi over 4. So that's pi over 2 as well. So the period is pi over 2, however you want to get there. 0 to 0 or asymptote to asymptote. Either one is fine. Phase shift, well, it hasn't shifted left or right, so 0 for the phase shift. And then the only thing left is b, but the period is equal to pi over b. So probably don't need to cross multiply on this one, I hope. You just tell by looking that b needs to be 2. So y equals tangent of 2x plus 1. Other questions? 5, 6, 7, or 8? Number 8. All right. Let's see. Looks like the middle, in between -3 and -5, would be -1. If these axes were labeled better, it'd be helpful. So there's my new midline. In fact, I'm going to go ahead and account for that. Vertical shift, down 1, -1, or down 1, either way. I'm going to highlight one cycle. You can pick which cycle you highlight, especially when there's a bunch showing. I'm going to pick the one that to me makes the most sense. That's one cycle. The period. To find the period, again, it's like tangent. You have options. You can go. You can measure start to finish. So like one cycle. You can measure peak to peak. That would be the same thing as one cycle for cosine. You can measure valley to valley if that's easier. As long as you're measuring from any spot on the graph to its corresponding point, one cycle away, you can get the period that way. I guess we normally go from start to finish. So if we go from -pi over 2 to pi over 2, then that period is pi. For this one, it would be easy to go. It would also be easy to look from valley to valley, because the valley's on the axis, so it's pi away. So again, you can measure the period a bunch of different ways, but for this graph, you should always be getting pi. Let's see. Amplitude is how high above the midline we are. Well, it looks like we're 4 up and 4 down. So amplitude is 4. Phase shift, you have 2 equally good options. I could go left pi over 2 or right pi over 2. Or left however far this is, or right however far that is or that is. So you got an infinite number of options for phase shift. But I'm going to go left pi over 2. And for this one, right pi over 2 would work as well. So my equation then, y equals 4 cosine b. So if period equals 2 pi over b, well, again, you can cross multiply if you need to, or hopefully you can just look at that and say, well, b's got to be 2 in order for that to work. Andrew? Well, there's a couple ways to hold that thought. The question was, is that graph flipped? Well, I'm working it as if it starts right here. Hold that thought, though. When I finish, I'll work it a different way. So b is 2. X minus pi over 2 would shift it to the left, and then minus 1 for down 1. That's one of many possible answers. So Andrew's question is, wait a minute, isn't that just a flipped cosine graph? So if you see it as a flipped cosine graph, then what would that affect, Andrew? The first number would be what? Okay. The period's the same, so it's still 2. What's the phase shift if it's flipped? None. And so either one of those answers would be okay. So this second option is flipped, but no phase shift. And that is completely okay. So on the test, my key has like 3 or 4 answers for these questions, because there's 3 or 4, reasonable answers you could put for that equation. And I think the 2 I listed would be the most common. Again, you could get really crazy and say, well, it has a phase shift and it starts over here at whatever that is, 2 pi, and it's flipped. Like you could put all that in there and be right. It's just that'd be complicated. But there are more than one way to describe these equations. So that was a good question. Anything else from this worksheet? Adam?
Number 6.
Number 6, another tangent problem. All right, we're going to say amplitude's 1 because it's always going to be 1 for tangent. We're not worried about stretching it up and down. It looks like it makes its wiggle right at 0, so there's no phase shift and no vertical shift, so that's kind of nice. Looks like the asymptotes are at negative pi and pi. So Adam, what's the period for that graph? It is 2 pi. So we got to be careful about b now. Period is 2 pi. 2 pi equals pi over b. That does not mean b equals 2, right? If some of you have done enough of these, you know what b is. Others, probably most of us, are going to cross multiply just to be careful. And we get b equals 1/2. So y equals tangent of 1/2 x. So the 1/2 served to stretch it out left and right.